All right. All right, hi everybody. This is Alex Borde from MetalSoft, and this is a demo of our site ZTP ability, which is the ability to stand up an entire site from top to bottom, and another demo of our consumption part, where we deploy the resources that we just provisioned in our data center. So this demo is going to show how we provision 3 switches. We actually have John in the data center with us, and John will be basically plugging in 3 switches that we have. You see those power cables hanging there. There are 3 switches on the top of the rack, and then a couple of servers, one somewhere closer to the switches, another one somewhere below, and they're all unplugged now. And John, can you say hi to the camera? Hey, John.
Okay.
All right, and so John will be plugging them in, and once he does that, then the switches will appear in our MetalSoft infrastructure in the back office interface that we have here, and this black interface here on top is our back office interface, the admin interface, what we call the admin interface, and we have a data center already configured, and then we don't have any switches and we don't have any servers registered in our system. So once we plug them on, they should appear in our interface. So, right, let's do it. Power them on, plug them on. So yeah, so maybe start with let's start with the spine switch, and we can see how it appears in the interface. Okay. All right, so it is a Dell 52 series, I believe. Okay, so we're gonna wait a little bit. I have terminals here. There's a terminal server, and all of the switches are connected to the terminal server. Actually, let's show. Yeah, so you can see the switches they started doing Onye, and they got the image. I believe. Oh, so they're in the boot phase. Sorry, they will receive the image soon. Okay, Onye install OS. Okay, so it's gonna go through this pages. It's gonna deploy everything. I guess we could also add the other 2 switches as well.
Yeah.
Okay, or actually maybe wait until this one appears in the interface before we plug them on. Oh, okay, that one is started. Okay, that's fine. All right, we have this spine switch is registering. We should also see the other 2 switches. I'm gonna switch back to John here. So you'll notice that John isn't doing anything, which is the whole point. We want to make sure that there's nobody that has to do anything when the infrastructure gets deployed. And imagine a fully fresh site with no servers and switches. Obviously, this is a demo environment. We have a lot of other servers and switches here, but imagine a completely empty edge site or a new site in an enterprise, and just put everything in and just plug them in, and that's it. Okay, so we have some spine and the lists that are coming up. So this whole process takes about 13 to 15 minutes, I believe, for the spine switches and the leaf switches to be up. While we're waiting, I think what I can do is give you a bit more intro on how this works and what are the next steps. So, I mean, you all know the ONIE process and the ZTP process that Sonic supports. We're doing both, obviously, but after the ONIE and the ZTP processes will be finished, MetalSoft will use the RESTconf to start the configuration of the additional things that need to be configured, like the BGP portion. The end result that we're aiming here is for the entire site to support an EVPN setup, right? Because that's what we use in our normal setups. Okay, so you see that this the spine switch has been installed and it's now rebooting. The other two switches are still in the process of being set up. I think there's only one that popped up here. It wasn't. Okay, and yeah, and as I said, we do apart from this initial configuration where we push the original, the initial configuration, everything else we're doing via the RESTconf interface. So there's nothing that we're not using configurations in a script file that gets pushed, but rather do everything correctly. And after this step has been done, then we will be able to register, go on and do the second step, which is the registration of the servers. I know this is networking specific demo, but our application is able to do both service and storage and at the same time. So customers can use, there's the second leaf as well. Customers can choose to use either only the network provisioning part, which is intent-based, and I'm going to show you how you consume the resources, how you do the network provisioning using this interface here, this white one, which is the end user self-service portal. But we can also do the full stack. So we can provision both the servers and the switches and storage using the same self-service portal and the same intent. So in this demo, we're going to show it fully. But user experience is relatively the same for network only operation. Yeah, so now here with the Sonic part, we're at the second stage where we are running the remaining parts via RESTconf, I believe. So when they are ready, they should show up as active. They may take a bit more. And after they show up as active, I'm going to ask John to connect the servers to the power supply. The servers have been configured as with DHCP enabled, and when they're plugged in, they will start issuing the HCP request, and the zero-touch provisioning process will start for them as well. Also, do note that we have this as a service consumption or network as a service consumption mechanism where basically the registration process only means that you're taking the site to a point where it can then be consumed by the end user, right? So it's a cloud-like consumption model. It's not a traditional configuration, force multiplier tool, right? So it works differently. After the ZTP phase, the service, the switches, they are powered on, but the ports have nothing configured on them. But the servers, the switches themselves have a BGP configuration on so that they can talk to each other and set up a VPN, but they don't have any VPN configured. And then so they're just waiting for additional configuration to come in. The servers also are shut down. I'm still waiting for this for the switches to come in as active. Once the ZTP process and the second process, the stage ZTP is ready, yeah, system is ready to respond, restarting the configuration. So I think it's relatively close to what we have. I can also maybe show you the topology view of the data center. So while this process goes on, the switches are registered, they show up in the topology. Okay, and so I was talking about the ZTP process. So the ZTP process for servers is a little bit different. The servers will show up as shut down. They will show up as available but shut down. So the same process, the same concept applies there when those will be your resources, the common pool of resources from which you will start and allocate resources to various customers. When you're operating without the servers, you will be importing those servers in the infrastructure editor. They will show up as active. So you, as the end user, still manipulates the endpoints or the endpoint perspective, and I'm going to show you what that means. Even though the system will not be touching the servers themselves. In this demo, we will be touching the servers. Okay. So I think it's almost ready. So I guess the spine will be up soon, and then the leaf switches. Okay, let's refresh again. I'm gonna refresh again. Let's see. So while we're waiting, which although I think should happen in time, so I think I may want to show you around the interface. So this is our dashboard where you'll see all of the servers, storage, and switches that you have registered. And if you have many data centers, they will show up on the map, and you can use the address to identify the respective data centers, drill down to an edge site or something like that. And you can see also the system is ready. Let's see if it shows up now. Not yet. Okay. So carrying on with the rest, you will also see the servers here. Once we go through the registration process, you'll see the switches. Oh, this one is active. Okay, so this one is ready. The list will probably come up in a minute or so because they're very close to the same status. We have actually, maybe I want to show you a bit on how the topology is done right now. So we have a leaf switch, wine switch, and another leaf switch. And we want to connect also, they're connected like this, and we want to connect a server here and another server here. They are pre-cabled, so John has cabled them already in the data center from a networking perspective, from a cable perspective. The only thing that doesn't right now, the servers have been powered off, and they are just waiting to be plugged into the power mains. And we want to do that once the switches have been registered, because there's a process during the ZTP process where the servers will automatically discover their connections towards the switches. And for that to happen, the switches need to be active. Okay, so I think we're almost ready with the spines as well. With the leaf switches as well. Okay, so let me show you some more. So as I mentioned before, our application is fully multi-tenant, right? And multi-vendor. Currently, we support Sonic, Dell Enterprise Sonic, OS 10, Cisco, Juniper, and Cumulus, and but more vendors will be added soon. We also support multiple vendors on the server side and the storage side, and the objective is the same. We are intent based, so everything that you design from the customer's perspective will be abstract, meaning not specific to a particular vendor. And that helps you upgrade, have different clusters with different hardware, and just have a seamless operation between them. So this one also says system is ready, so we should see it up and running in a second. And this one will probably reach the same status. Okay. Yeah, my colleagues are telling me that there are a little bit more steps after the system. It shows the system is ready. So yeah, I guess that's it. So I want to show you also this part here, the subnet side. So we have some subnets that are pre-configured from which we allocate on the one or SAN or OB subnets to the various uses. We have our own embedded IPAM system, from which we allocate these numbers. And as I mentioned, our solution is also multi-tenant, meaning each customer has its own infrastructure. So like this editor here, we have multiple end users, and each end user can have multiple of these infrastructures, and all of the networks that are created on the on this portal here are separate, are provisioned in separate layer 2 networks. They receive different VNIs. This concept is similar to the Amazon VPC concept, right? So this ensures that each individual tenant has a separate network. Let's take a look at the switches again. Okay, so the second leaf is also active, so we're waiting for the last leaf to come up. Yeah, so this tab here shows the infrastructures that customers or the tenants have provisioned. And On the template side, you will see operating system templates for both operating systems and for both servers and switches. And you have the option of customizing the initial ZTP configuration, for example, for the spines or for the leaves by using this interface here. So ZTP.json, and you can edit it directly into our portal here. This is served during the provisioning process, and you'll notice that there's some variables that get pre-configured. They're replaced at runtime when this is served over to the customers. The more interesting one, I believe, is the config.db. This one here. So you'll have a lot more configurations for the ports and the host name that will receive, and the gateway address. These are variables that are pre-populated by our system automatically. Currently, because this may be a question that you're thinking of, currently we make a distinction between the spine and the leaf during the provisioning process based on a couple of settings. We can do it based on the model number, and which means that you have a spine switch which is slightly different than, has a different model than the leaf switches, then it becomes a spine switch automatically, or based on MAC addresses. So you have to fill in those MAC addresses and say this MAC address of the system, of the chassis, is of a spine, and these are for leaves, and they will automatically become leaves. We also want to do it, but it's not yet in the product, a topology-based setup where, based on the topology and how the links are configured, the system will get to be either spine or leaf, and then you will be able to override it based on the on the topology, on the MAC address or the model of the switch. Okay, so let's see where we are. Okay, so we have everything up and running now, so we should be good to go. I think maybe if you want, we can show how the switches look like before I plug in the servers, or maybe let's plug in the servers. John, if you're with us, go ahead and plug the servers in while and in the meantime, because that will take some time as well, and I will get into the switches to show how they look like, after we do that. So I guess first server is connected, and there's the second server that's below somewhere. There are two Dell R240, if I'm not mistaken. So they're shorter. You don't see the third. Okay, all right. Okay, so now we'll wait. Again, the same process is it's very similar. I cannot show you their outputs because they're not connected to the terminal server, but what they'll do is they will issue a DHCP request. We will intercept that DHCP request, and the servers will start automatically register themselves using Redfish. So they will show up in this servers tab here, where we have nothing right now. Okay, so while they do that, let me get you into this switch here. Admin, and for this password here. Okay, and Sonic CLI. Okay, go BGP. Maybe not show BGP. What was the command? Show BGP all neighbor. Okay. All neighbors. I'm gonna expand this one a bit more. Okay, so BGP neighbor is on Ethernet 10. So at least it sees a neighbor on Ethernet 10. Okay, let's see this other one here. So BGP all. Same port, okay, and let's do the same here. Like CLI, BGP all. Make this bigger. So this is a spine, you have two connections, 501, 502, 502, local IS number, and 501. All right, so we're good. We have a BGP session going between the spines and the leaves. So let's see if we see any server. All right, and we see the service now. Registering. Okay. So we're gonna wait for them to go through this whole registration process, and during that registration process, which has already started, we already know some things about the service. You'll see, we'll start seeing some, interface information being populated here. This is very important. This interface related information, which basically says which server port goes to which switch port. That's important because that helps avoid all of the configuration issues related to that. So customers don't have to care about, the switch ports. The end users don't have to care about anything like that. They will just, I'm going to show you in the interface here, they will just have to connect the server to another server on a particular port, and that's it. The system will take care of the rest. So this is the process that happens during this phase here. And there are multiple ways in which we determine this information, but it's basically via LLDP that is available in the Redfish information, the Redfish. Okay, so now we know a bit more. If you noticed before they were standard Dell servers, now these are Dell EMC vPlex server, some other type of server. So the system goes and determines additional information and adds it to the database. Not yet. I guess it's in the process of doing that. So the system is also backwards compatible. If the servers don't have this information in Redfish, which many servers don't, especially legacy servers, this information will be obtained by booting a server, booting an operating system and using that operating system to query LLDP information on the servers. And as I said before, this is not so if you're going into a brownfield environment where you don't have, let's say you're in the networking group and the server group is doing its own thing and you have no control over whatever they're doing on the server side, the servers can also be imported, right? So right now we're adding them like this, but they can be imported into the system and they will show up exactly in the same way as you see. They will be called active, meaning they're active and allocated to a particular customer. And they will show up in the user interfaces here as already active, but the network configuration connecting to them will only be changed when we hit deploy here on this part. Let's do a refresh and see where we are. Okay, so we're still registering. So that gives me an opportunity to maybe walk you through some of our other capabilities. So you'll notice that we have concept of server types. So when a server gets registered, it gets allocated the stock keeping unit, like this numbering scheme here. It says 8 core, 16 gigs of RAM, and 1 disk. And these server types are important because it gives you the opportunity to meter the utilization of these servers and charge the end user based on their utilization. And the same can be done on the networking side as well. You'll see here on the users and on the billing side, you'll see that we accumulate utilization for different users. Let's say this user here, for example, accumulated some utilization from on the networking side, download and upload. So we can charge based on that. I can also look at my utilization in the past on an infrastructure that was, well, maybe I don't have infrastructures here on this environment. But if I did some traffic, it's going to get accounted for. And also the subnet utilization has also been accounted for. And in the future, we'll plan to add more elements such as the number of ports that were used, and obviously the traffic is already accounted, but maybe you want to charge based on the available bandwidth. Okay. Oh, sorry, we were the server stage, seeing what's happening. Let's see if the networking part has been determined. Not yet. Okay, so I guess we're still waiting. The system will also populate the firmware part that will determine details about the firmware components and about the disks. Okay, so the disks have been determined. So there's an SSD in the system. Okay, and also want to show you on the workflows part. So this workflows is a mechanism that allows us to do things that have not been built into our product, and workflows are attached to any provisioning, or can be attached to any provisioning step. And it can be used to do things like integrate with ServiceNow, so that, or other solutions like that, orchestration solutions or back office solutions. And now we have the option of using that method, using ServiceNow as a way of approving certain requests, for example, or also there's another option of integrating with ServiceNow by having ServiceNow create the infrastructure in our interface. So certain end users may choose to not use this interface here at all, and have their own systems or Terraform pipelines, infrastructure as code pipelines created to do the provisioning part, which I'm going to show you in a second. And so everything can be done, as using the APIs. So, for example, tasks that can be added to the workflow processes are simple bundles, SH exec, HTTP requests, and all that. And once you've done that, then you can create a workflow. Once you've done those stages or tasks, then you can have a global type of infrastructure or run something that's at the infrastructure level that will execute those tasks in a sequence. Right? So they will look like this. And you can select one of the existing tasks. And obviously you can reference variables and secrets. Okay, so let's see what the servers are doing. Okay, network interfaces are up for this server. And it's probably going to do the same thing for the second server. Let me see. Not yet. Okay, so we're still waiting for this one. Okay, so what's also important is that we record all of the activities of all the servers and all everything that the customers have done and collect information from switches and servers into a single event stream. And this is important because it can act both as a security audit system, also as an event-based system where you can react to issues and solve, determine if there are problems. User authenticated, everything that's security related, but you can also see additional information like debug information. There's not debug information. Server firmware vendor version updated. Okay, so server was updated with tracking personal. So you see everything that the system has done. So the DHCP status changed. Was kernel now status deny request, which means it got an IP and it can be used. Okay, unavailable. So this is what we're looking for, right? The system means I'm ready to be allocated, but I'm not yet set as available in the pool. But I'm going to go ahead and set it as available. Action succeeded. Okay. And we're going to wait for the second one to do the same thing, and then we're going to start provisioning the infrastructure. As I said before, this available state here, or used state, I think, will be the state in which servers will be imported into the system if they don't, if they are already deployed, or if the server group wants to manage their own servers. So in a scenario where the server group and the network group are separate, completely separate, let's say they don't talk to each other at all, then the server group will just put the servers in the rack, just like John did, and cable them, just like John did before, and then plug them in, and that's it, right? So they don't have to communicate anything to the server team, to the switches team, the network team. But at the same time, the network team will just give them the credentials to manage the servers themselves into this system. Okay, so this server is still registering here. Well, I'm gonna give it some more time. Let me show you, the template side. So we have two types of templates, as I mentioned, the Sonic templates and the ESXi templates or Ubuntu templates, and all operating systems are provided by us or major operating system. The way we deploy it is unique on the market currently. It has, or very few other solutions actually support it. And we're using we're using virtual media. We call it out-of-band only deployment. So we essentially build an ISO based on golden ISO that you have in the database, which is, in the case of ESXi, this particular ISO, which is stored in our repository here. And then we inject Kickstart configurations into the ISO as it gets prepared for each individual server. And so that the Kickstart configuration has details on about, like, for example, initial password or the WAN interface address, and instance subdomain request, and how the network needs to be set up and all that, which the customer can modify, as you can see. And then you use this mechanism to deploy the operating system exactly how it needs to be for each individual server in one go. The advantage of doing it this way rather than the old-fashioned PXE way is that you don't have to have an in-band connection. So we can stay, as MetalSoft agent is only residing on the out-of-band network and doesn't have to have active network, any network connection to the in-band. So in our diagram here, the MetalSoft agent resides somewhere where it has access to the out-of-band switch. So I forgot to mention that there's, basically this is the agent. There's an MetalSoft controller, this interface that I'm showing you. And the agent is connected to the out-of-band switch, and the out-of-band switch is connected to the management ports of all the servers and switches and spines. So something like that. Okay. So let's check to see if my servers are up and running again. I don't know why this one takes this long. And there are different types of servers, so different servers take different amount of time depending on various things. So maybe that's why it took a little bit longer. We're gonna give it a little bit more time, and then we're gonna start the provisioning process. I want to show provisioning process with two servers, so I can show you the both ends of the provisioning process. Oh, and you'll also notice this stockkeeping unit that was allocated here. Oh, and yeah, maybe because now we should have the firmware also entered, I can talk a bit about this. So we manage the firmware of these servers as well. And we have multiple ways of doing it. You can change the firmware while you're doing the provisioning. It's currently only possible via Terraform. So you can, in Terraform, you can specify which firmware versions you want for each component in particular. Or you can do what we call automatic firmware upgrade. So if you enable automatic firmware upgrade and you set up some policies, like for example, upgrade Hydrax, and you issue something like ask for confirmation, what this will do is that upgrade Hydrax. But and I add some, rules to it, like server component name equals Hydrax, right? And what this will mean, it will mean that every night the system is going to pull the available firmware from Dell in this case, and if it matches these conditions, it's going to send an email to the tenant of the server, or it's going to deploy an upgrade automatically if the server isn't in use. It's going to work more or less the same way as upgrades on your server on your laptop will work. You see a message saying, "Hey, this one, yeah, your server needs to be upgraded. Are you okay with the upgrade?" And yes, then we'll do the upgrade automatically for you. So okay, so this server is now also available, which is what we want. And I'll go ahead and set it to available so we can use it to provision things on it. Action succeeded. All right, that's what we want to see. Okay, so let's go here in this interface here. So I'm gonna click here, create your first instance array. I'm gonna select my server configuration. So one will be, you have two server configurations because the servers are different. So I'm gonna select this one first. I'm gonna say install ISO local drives. Say ESXi. I'm gonna leave everything else as default. Click create. Okay, I'm gonna do the same thing for the second server. Again, if this would be a situation where we would only control the servers will already be in this infrastructure. Okay, but they will show up without this network connection. But if you're doing it this way, then the network connection will be like this. Right, and so let's see deploy. This will create, deploy the operating systems on the servers, but also at the same time allocate subnets and deploy two layer 2 connections actually a single layer 2 network that will join those two servers, but also provide internet access to those servers. So in this phase here, when you hit deploy, there's a few checks to see that it's able to connect to the servers, and so it takes a little bit longer until it does that initial verification. And now it started the actual, deploy. I think one thing that we could do is to go and see the console of the server. Yeah, this one doesn't work yet. Let's see the Hydra console. I'm typing root and pass. Okay, let's see the console. I think the server may be shut down. As is closed while the server is power off. Okay. I will just power state on. I'm just gonna leave it like this. I know I have had issues with the console before. Okay, now it works. All right, so I'm gonna just leave it like this. And is it the same thing for the second server? That's the 190, is 188, okay. So I think we could make these servers boot faster if we remove all of the PXE related steps, because they're not needed in this environment actually. Am I on the right server? Server D7 something something. Okay, copy. Oh, it's root, not admin. Okay, so you'll notice that in this first server, it's in the ESXi installer. Okay, remember what the problem was with you gotta start second time. Okay, so Yeah, both servers are now in the ESXi deploy stage, and yeah, they will go through this process. And at the end of it, it will show, it should be in the ESXi phase. But the networking will also need to be set up. I don't know if it was already set up or will be set up at the end, but it's in this process anyway. So there's the issue with the console. My colleague are telling me that it's because uh, it's a known issue that servers need to be provisioned first before it works. But this limitation will no longer be a problem in the next release. Okay, so now this the server is in the final provisioning stages, I believe, or in the process of, I don't know ESXi deployment process that well, but ESXi in general is pretty fast to be deployed. Okay, so servers are used. I can show you while it does that. I will show you through the interface how it looks like from the admin perspective. If you're a support engineer, what you can use this interface to see the details about who uses what, right? And you can see that from the server perspective and from the switches perspective. So from the server's perspective, these servers are now used by me, right? And I'm using them on this infrastructure for this particular instance. And that is, you can see the allocation that was done for the servers. You can also see on the network interfaces tab that this port here is used for this one network. Now we have two IP addresses that we allocated and they're connected to these leaf switches, and I got the VLAN allocated for the connection towards the server. And I want to show you also on the switches side how that looks like. So let's go on these leaf switches. That server is connected to one of those leaf switches. Okay, so I have Ethernet 0 goes to server 38, and this other one also to server 38. Both are used by me. Right, so this is sort of the other end of the connection. We only show and we only touch the ports that go towards that are discovered as being connected or have been imported as being connected to a particular server that we care about. So it doesn't show all the ports in the switch, just shows the ones that we care about. And our system is a single source of truth for this entire setup, which means that you can always reprovision switch interfaces, right? You click on this button and it will reprovision that interface. It will take it back to where it was. And you can yank out the switch and put another switch in its place and have the switch go to the ZTP process, and then you can just click reprovision the switch interface. Yeah, so it's the same process as with storage. I haven't had the chance to show you that, but if you have a storage pool configured here, you can drag and drop a storage volume onto the servers, and then you will see them, just like you do with the servers, you will see them attached here. And I'm gonna try to take a look now at my infrastructure um, in the billing section to see if I've accumulated. Oh no, the infrastructure hasn't yet been permissioned. So once it's done, once it's in the deployed phase, I'm gonna see some utilization being allocated. I can also have a subscription for certain resources like servers or storage, and that can be, can change the way they are built. There's also support for, since we are waiting, there's also support for multiple types of authentication. So certain customers will want to provide end users with, both SAML and LDAP and other authentication. We also have our own built-in authentication system. But SAML and LDAP are probably what you're gonna use um, in the system. You'll notice, I don't know if you've noticed that it said ESXi was installed successfully. And I believe we're doing a power off now to finish off a networking part, and then we power the servers back on into the provisioned networking phase. Okay, so I was talking about the way we do authentication. So we have multiple ways of doing authentication. We also have full RBAC capabilities. So you have roles and permissions, and you can create custom roles as well, and allocate those roles to the various users, and they can do various things based on the respective roles. So we can operate in an enterprise setting, and that's with more complex security requirements. There's also a job queue, and you can see when things go wrong. You can see these things that are ongoing and what has gone wrong and so forth. And if something goes wrong, then you can go in and you can retry or skip that operation. Let's take a look at the topology view, see how it looks like. Okay, so we have two leaf switches, and the servers connected to those two leaf switches and the spine. Okay, that's good. Okay, this has also been installed successfully, and now it's shutting down. Okay, this one has been rebooted. Oh, shutting down. Hot system power off. Okay. Okay, now it's getting, so it's rebooted, and now it's getting into the, I think it's on the provisioning side. There's a view that I'm going to show you briefly that you can use to view, to see what's happening behind the scenes if you're interested. So it goes to these phases here. Right, so now it's on these stages here, and it's going to go through, it's going to delete the operating system image that was pushed over, and then it's going to wait for the instances to be ready. And I believe that's it. I'm going to leave it like this. It will, it will progress slowly through this process. This is actually a very important feature. Right? If something happens along this line, you see this one has turned green, and then on the other one's green, and then this one will wait until all the instances are ready before it proceeds. You'll note this is very important because it provides the operator with not just visibility, but also a way of fixing a problem if something goes wrong. So let's say one of these steps, like delete operating system image, didn't work properly. For some reason, maybe the storage of the agent failed at that particular time. You can see that that has happened, and you can retry the operation from where it left off. You can fix the problem with the storage in the agent and retry, and we'll continue from where it left off. Right, and this is a very important because it keeps the system in a very consistent state. It doesn't allow you to to have something on the server or the switch port and another thing in our database, because then the single source of truth will no longer be the single source of truth. We will be desynchronized from the actual reality in the field. But this mechanism doesn't allow deviations from that, except of course from when some admin will go on the switches and do things manually. We are working on an ability to see if that's the case. It's not yet in the product, but in the future, we want to have the ability to detect those configuration drifts and alert if that is the case by comparing, how it's supposed to look like with what's actually on the switches. So yeah, one server was a bit slower and went through this process. Slower. What's different between them, I believe, is the iDRAC version, or the hardware itself, the hardware generation. Okay, so it went, and now it's waiting. Okay, give server back to customers. I believe this stage here will power on the servers, if I'm not mistaken. Yeah, see, the servers have now been powered on. All right, provision, 100% success. This one is also ready. Servers are now powering on. And what I can do is I can use this remote console, see if it works. It should work now. Oh, not yet. Okay, we'll check this later, I guess. So this remote console will show the same output as this one. Oh, my colleagues are telling me that you can't have both these ones and the other ones. 188. So this one, I'm gonna let them finish, and I'm gonna use these ones here, and then we're gonna try this other remote console as well. This is a new feature. We just added this, so it has some quirks. Okay, to manage, go to instance dash 192.168.6473. Oh, this one. All right. So I'm gonna have to login name, password. So let's test. I believe this is how I do the testing. Okay, let's do the same. Okay, so this one is on 192.168.64.2, and this one is okay, ping address .2. 192.168.64.2. Okay. All right. Oh, good. So this basically means that we have a connection between server 1 and server 2 on this network address here. And maybe we can show a bit how this looks like in the Sonix CLI. Keep forgetting this password here. Okay. This is the spot. No, this is the listeage. Okay. So Sonix CLI. Show interface. Actually, let's look at specific network interfaces. Switches. Go to one of the leaves. This is leaf 85. Leaf 55. Leaf 55. 85. Which interfaces? And only one interface should be provisioned, which I believe is this one, VLAN ID 100, server ID 38, interface MAC address. Okay, let's see it from the server side. If 85, Ethernet 1 and Ethernet 0. Okay, so Ethernet 1 should be my okay. Ethernet 1 is up. So interface status. Okay. 18 interface 78. Okay. So we're up. So interface VLAN, I believe. Okay. Okay. So we have a particular VXLAN and an Ethernet, the physical port attached to VLAN 100. So, and we can do the same thing on the other leaf. Admin. Okay. Linux CLI. So interface. This other server will have a different ports, some different ports, I believe. Leaf 84, Leaf 84, Ethernet 1. Okay, same interface. Okay. 18. Each network has an ID, right? And this the network has ID 8. And INT 74 means the infrastructure 74. So it means this yeah, project here that I've created. So it's easy for you to see, to connect the dots between what you see in the system and what you see in the actual switches. Let's also show the VLAN 100. Okay, so we have also this VXLAN attached to it, and the Ethernet port 1. So that concludes our demo. What you've seen here is basically complete site setup from top to bottom. I didn't have anything, and now I have spine switch, leaf switches, servers, and a provision configuration so that these two servers that are that belong to one tenant, myself, can talk to each other on layer 2 network, and they have layer 3 IPs, IPs allocated obviously on the interfaces. So I want to show you how it looks like. So it looks like this, and there's a VXLAN, VVPN, VXLAN tunnel being created over the layer 3 configuration that we have here with BGP being configured between the leaves and the spines. And then the server is able to be server, is able to ping this other server, and everything checks out. So yeah, there you have it. This is what our product can do, and it is it's a very powerful technology, and it's able to do actually a lot more than I've been able to show you today. And we have on the roadmap very interesting features. So yeah, stay tuned. Thank you very much. If you have any questions, you can always reach out to me, and I'm going to show you just 1 second. So to reach out for questions, use Alex at MetalSoft.io, or to inquire for any questions, or to register a deal with us, or get more details on a deal, how we can do a demo or something similar. Reach out to sales@MetalSoft.io. Obviously, also don't forget to check our website at MetalSoft.io. And more information can also be found at docs.metalsoft.io. That's it. Thank you for watching.